Alright, lesson 12.4 is on transformations, and this of course is geometry. We're going to talk about just the very basics of the different types of transformations. A transformation, by definition, is a change made to the location or to the size of a figure. Okay? There are different kinds of transformations. Some change the size, some change the location. The new figure that's formed by the transformation is called an image. Right? So the first type of transformation that we're going to look at is what we call a translation. Some students call this a slide. A transformation in which each point of a figure moves the same distance in the same direction. This is a rigid transformation. The shape does not change, just the location. Notice here in the example I have a right triangle, triangle ABC, and I'm going to slide or translate this to the image here, A prime, B prime, C prime. So it kind of went to the right and kind of went down, or down and to the right. What I'm going to do is I'm going to use these two key points here that I have marked. I went from -1, 1 to 3, -2. So horizontally, this thing went 1, 2, 3 spots, excuse me, 4 spots, I can't count here, 1, 2, 3, 4 units to the right. So it slid 4 units to the right. And then from here it went down 1, down 2, down 3. Then it went 3, 3 units downward. And that's how I would describe it in words. I don't think I'd use the word slid. That looks pretty silly. I don't even know if that's a word. So in this case, we're translating or shifting it or sliding it 3 units or 4 units to the right and 3 units downward. That's the type of translation that we're looking at. Okay, notice that it slides upward, downward, right, left. That's how a translation works. A reflection's a little bit different, and we'll use a different diagram here, but it's a transformation in which the figure is reflected or flipped in a line. Now, one way that you can kind of try to picture this is if I have this and I flip it over, let's say, a vertical line, or if I have my hand and it flips over. That's what we're talking about with a reflection. But we'll need a diagram, so we'll draw one out. Okay, now let's go to the reflection idea. It says, tell whether the transformation is a reflection. If so, identify the line of reflection. That's the line in which one side is flipped over the other. Okay? So in this case, I have a diagram. I have my original figure here to be triangle ABC. I have my image to be triangle A prime, B prime, C prime. Do you see how the one was flipped over the x-axis? The x-axis is my line of reflection. So yes, it's a reflection, and the x-axis is my line of reflection. Look at the one here that I have. Looks like 2 arrows, like you'd see somebody holding at a corner of a street intersection there. You've got 2 arrows that are kind of pointing to one another, and you see how this image is from this image here being reflected, from this figure being reflected over to here. If this is my original figure, then this is my image. If this is my original figure, then this is my image. And you can see that the y-axis, yes, it's reflection, and it's the y-axis that is the line of reflection here. So now I go to this guy here, and it looks kind of like maybe the x-axis might be my line of reflection, but it's not a reflection. You see how the pointy part is kind of going to the top? It's still going to the top. If it's flipped over, it'd be going towards the bottom. So in this case, this is, as it turns out, this is a translation. I brought this figure, triangle ABC, downward, looks like 3 units to get the image A prime, B prime, C prime. So this one is not a reflection. Now, if a figure has a line symmetry, if a line called a line of symmetry divides the figure into 2 parts that are reflections of each other in the line. Okay, so we have symmetry here. this whole entire figure here has symmetry, with this being the line of symmetry, the y-axis, the entire figure, not just one part or the other, but both parts combined. So I have some examples here, and I want to determine how many lines of symmetry each figure has, because sometimes figures have more than one line of symmetry. I have what I tried to draw here was an isosceles trapezoid, which means that the legs are the same length. And it has one line of symmetry, and I'm going to try to model it right here. It would cut right down the center. It would be perpendicular to the two bases here. And so that this part here would be the same as this part over here, and this part here the same as that. That would be an example of a line of symmetry. So this one has one. Now a square has all sorts of lines of symmetry. I could put one right down the middle like this. I could put one right across like this. But I could also put one that contains the diagonal this way and contains the diagonal this way. If you look at this diagonal being my line of symmetry, you can see that this triangle is reflected over here, and I have symmetry, and I have 4 lines of symmetry. My last example, no matter where I try to place it, I am not going to be able to draw a line of symmetry here, so this one has 0. So now these lines of symmetry are going to come into play later also in your geometry class. Now I've only described 2 types of transformations, the translation or the slide, and the reflection or the flip. But there's also rotation, sometimes they're called turns or spins, and there's also what we call dilations, where you're stretching an object or shrinking an object, kind of like you did with silly putty, when you take your silly putty, put it over the Sunday comics, get a picture of Charlie Brown, and then stretch him out like a carnival mirror. But you're going to discuss those in geometry. We're not going to discuss those here. Make sure that you understand the ideas of reflections and translations, and remember, practice, practice, practice.